Greetings and welcome to my YouTube channel. Today we are going to be looking at a very viral math questions in a topic known as sequences and series. And the question reads, given a series defined by Sn where Sn is equal to that sum, A. Find the nth term of Sn, and B. Hence, find Sn which is equal to the sum from n is equal to 1 to infinity of un. Suppose that the nth term is un. Okay, so I got this question from a maths editor, also called an equation editor. This editor actually is like a forum, and he also has an equation part that helps you to write out mathematical symbols, present mathematical formulas in a well presentable way. So after getting a question from the maths editor, I was now actually tempted to attempt the question in my own way. So the question is going to be attempted by Ken Elsin, and if you want to get to me, you can get to me via the email you see on your screen, as well as through WhatsApp using the number you see on your screen. So at the end of this video, if you loved the video, I will be more appreciated if you like the video. You can also share the video to your friends or to those who are actually interested in the field of mathematics, as well as you can subscribe to the video if you want to be receiving upcoming videos from this channel. Okay, so we start straight away with the solution of this question. The question says that Sn is equal to a certain infinite sum, and the first part of the equation we are supposed to find um, the the nth term of Sn, and that nth term is supposed to be un. Now, if you look at Sn, we can see that the denominator has no problem because it can be identified as 6 raised to the power n, because your denominator have terms. So if d of n is my denominator, then d of n is basically 6 raised to the power n. If I look at it very well, from n equal to 1, actually, for every n greater than or equal to 1, and I know that n belongs to the set of natural numbers. Okay, now the problem now is in my numerator. How will I actually deduce my numerator? To deduce my numerator, if I call it n of n, I can deduce my numerator in the form. If I try to write out my numerator first, those are the terms in my numerator. It's not good to write the sum. Let's just write out the terms that are present in numerator. The numerator, the terms are 1, 13, 19, 97, and so on. So I'll write 1 as 3 plus negative 2. Now I'm going to write 13 as 3 squared plus negative 2 all squared. Um, Following, I'm going to write 19 as 3 cubed plus negative 2 all cubed, and so on and so forth. So I can clearly identify that my numerator can be defined by 3 to the n plus negative 2 raised to the power n. And we also know that our n belongs to the set of natural numbers, meaning that it begins from 1. Okay, so from here we can actually deduce that our un, which is the nth term of our sequence Sn, is defined by 3 to the n plus negative 2 to the n, all divided by 6 raised to the power n. Alright, moving to the next part of the equation. The next part of the equation, the b part, is asking us to find Sn, which is equal to the sum from n equal to 1 to infinity of un. So Sn will be basically equal to the sum from n equal to 1 to infinity. Now your un was 3 to the n plus negative 2 to the n, all divided by 6 to the n. Now if I try to actually separate these sums, I'll get the infinite sum of 3 on 6 all to the n plus the infinite sum from n is equal to 1 to infinity of negative 2 on 6 ordered to the n. So doing this, I'm going to get the infinite sum from n is equal to 1 to infinity of half ordered raised to the power n minus the infinite sum from n is equal to 1 to infinity of 1 on 3 ordered raised to the power of n. Okay, so I can Let's try to make it more explicit this way. So I can try to identify that this first one is a geometric progression, like 2 to the negative n is a geometric progression of first term half and common ratio half as well. So I have the sum to infinity will be given by half on 1 minus half plus. The next is also an infinite sum and it's a geometric progression of first term I have negative 1/3 and common ratio negative 1/3 as well. So doing this, I'm going to get half divided by half minus 1/3 divided by 4 and 3. So in a nutshell, I'm going to get 1 minus 1/4, which will give me 3/4. Hence, I can conclude that Sn is equal to 3 divided by 4. Okay, so that is the solution to the equation. So I would like you to like the video, you share the video, as well as you subscribe to the video. And if you love the video too, you can also comment on the video. You can contact me through my email address as seen, or through WhatsApp as seen on your screen. If you have questions in mathematics that are also challenging, you can also send to me so that we see how we can produce the solutions. Thank you very much.